As you remember in the previous video, we discussed that the perimeter of a parallelogram is 2 times the length and the width. 2 times the sum of the length and the width. And we said here that this side can be considered the length or the base, and this side can be considered the width or the height. We use another formula to find the area. Area is whatever is included inside the perimeter. So the outside boundary is the perimeter, but the inside of the perimeter is the area. So the area of this shape of the parallelogram is found by the formula 2 times base by height, or 2 times length by width. So I want you to remember, whereas in the perimeter it is plus, in here it is times. We are going to practice on this, and we are going to find the area not only of rectangle, yes, rectangle with 90 degrees parallelograms, but other parallelograms as well, like trapezoids. But I want you, before doing anything else, to go to the very simple shape all of us know, and this is the square. And I want you to remember that the square is made out of 4 sides that they have the same length. So one side and another side and another side with the same length give me the perimeter, sorry, of the square. I'm sorry. Okay, but it's very important for us to understand how we find again the area of this shape. So the perimeter of this shape with length, this shape we know, okay, has length L. The perimeter is L plus L plus L plus L length, whatever is this length. Or I can say the perimeter is 4 times L, the perimeter of the square. If I'm going to multiply this L, which is the base, let's say, with this L, which is the height, let's say, or this is the length and this is the width, the area of the square can be found by the formula L times L, that is L squared. Sometimes they call this A, so the area of the square equals A squared. Let's see now how we find the area of other parallelograms, which are not so rectangle. Imagine that this is the parallelogram we have, and we cut it at this point, and we slide across the cut-off side. What happens? Let's see again. We cut it where the height goes across in a perpendicular form, and we slide it across the blue cut-off. Then we see that this part is fixing or adding a missing part and makes that shape a complete parallelogram. So if I consider this as my base, and in this sliding side I consider this side as my height, again the area of the parallelogram is base times height. So the area is base times height, as it was in our rectangle parallelogram, because at the end of the day this becomes a rectangle. So the area of this shape, it is found by the formula base times height. Okay, a common mistake students do, they think that they have to consider this as a base and the sliding side as the height. I want you to remember that the height is this, not the sliding, the one that it is perpendicular. We are going to discuss now another shape, the trapezium. The trapezium is a peculiar shape. It is peculiar because it has a large base and a smaller base on top, and at the same time it has sides that they are not quite as heights. It's called trapezium. Trapezium. Many are called trapezia. As you see with the flash over here, this trapezium, if we rotate it, can become also a nice rectangle. But the problem is that we need two trapezia to make a rectangle. And this has an impact on the formula. Usually, the formula of a rectangle is base times height. Yes? This is the case in here as well, but with a little bit of change. We are using as base the average of the large base and the small base. So we say large base and small base added together and then divided by 2. This is the average of the base times height as normal. But what height? Again, as you remember, This is the height. This is the height here. The perpendicular line, the one that goes straight down here. Okay, so this is the area of the trapezium, and we're going to use it often in our activities.